Okay, so let's just summarize. Chapter 11, impulse and momentum. We were forced into using impulse because we have forces that are not constant. So we can't use kinematic equations. So we learned about interactions from the new perspective of impulse and momentum. Isolated system, sum of the forces are equal to 0. Now, again, you could have an isolated system along the horizontal plane, but not vertical plane, so that's okay. We applied conservation of momentum in simple situations. Again, momentum is only conserved if you have an isolated system. And then we talked about inelastic collisions, and we didn't talk about explosions, but it's the same principle. Recoil, particle decay, it's kind of like an explosion. That problem with the carbon-14 is like an explosion, right? You have a carbon-14 that decays. It's kind of like it explodes. Okay, so you better know this really, really well. I mean, it's going to be on your equation sheet, but you got to know how to use it. And you don't know if you're going to use this part or that part or who knows what. You got to know the whole thing. And then again, if the sum of the external forces is 0, delta P equals 0. If delta P equals 0, it just means P doesn't change. So P is constant. And this thing here, if the raindrop does not rebound at all, you can calculate the force that the rain exerts on the roof. But if it becomes hail, which is frozen, right? And when it rebounds, a perfect rebound, so this speed equals that speed. When that happens, the force that now it's hail on the roof is twice what it was without the rebound, right? So rebound has twice the force that the non-rebound does. And then if we have isolated systems and collisions, if we have hard spheres, obviously momentum is conserved because of that, but also if we have hard spheres that don't deform each other or anything like that, kinetic energy is conserved. That's called an elastic collision. Okay, if we have grapefruits, especially if you think of rotten grapefruits, then when they collide, they're going to deform, right? And so, but still momentum is conserved because it's an isolated system, but kinetic energy will not be conserved. So you just got to know those terms, what an elastic collision means and what inelastic collision means. And that's it. Thank you.